Here we have an investigation in which a bar magnet is thrust in and out of a coil. 3 different types of coils, a solenoid in other words. Give the independent variable for the investigation. This means the variable which the experimenter altered between the treatments, which the experimenter made different between the 3 treatments. Suggest a dependent variable, the variable the investigator was interested in measuring to see what effect the independent variable had on it, and which variables must be controlled. In other words, kept constant between the treatments so that the test is fair. The investigator made the 3 treatments differ in the number of loops in the coil. This is the independent variable. He probably wanted to see the effect of this on the voltage induced in the coil, or the current strength induced in it, which is why he's placed a meter inside the circuit to measure this. To make the test fair, he should use the same strength of magnet in each of the 3 treatments and the same rate at which he raises and lowers the magnet. Those are the controlled variables. So what is the focus question being asked? Generally, a focus question can be written in the form, how does independent variable affect dependent variable? How does number of loops in a coil affect the voltage induced in it by a magnet moving relative to it? Looking at the readings, what are the results of the investigation? We see that there's a low voltage in the first treatment where we have few coils. In the second treatment, where there are more numbers of coils, we have a greater voltage reading. And in the third, where we have the most number of coils, we have an even greater reading. Therefore, what is the conclusion to this investigation? How does number of coils affect the voltage induced? The voltage induced in a coil is proportional to its number of loops. Proportional to means, or we could say directly proportional, the more, the more. The more loops, the more voltage. How do you think that the strength of the magnet and the speed at which the magnet is moved would affect the voltage induced? It's reasonable to think that a stronger magnet will induce more voltage, and so will moving the magnet in and out more rapidly. Another way of saying this is that the voltage induced is proportional to magnet strength and magnet speed. More magnet strength, more voltage. More magnet speed, more voltage induced. What is a more precise or general way of saying this? A magnet has a magnetic field around it. A conductor is within this field, and when the magnet or the conductor move, when there's relative motion compared to one another between the magnet and the conductor, then current is induced. So what must be happening in terms of magnetic field for the current to be induced? For current to be induced in a conductor, it needs to experience a changing magnetic field. What do these 2 variables, strength and speed of the magnet relative to the conductor, have to do with changing magnetic field? The rate of change of magnetic field can be increased by using a stronger magnet or moving it up and down faster. What does rate of change of magnetic field? Change of magnetic field per period of time taken to make that change, which means the stronger the magnetic field given by a stronger magnet, the more it can be changed as it moves up and down, and the more rapidly it's moved up and down, the less time taken to change a magnetic field a certain amount, and therefore the greater the rate of change of magnetic field. So what is the relationship between voltage induced across a conductor and the rate of change of magnetic field experienced by it? They are proportional to one another. The voltage induced across a conductor is proportional to the rate of change of magnetic field experienced by it. Change the magnetic field at a greater rate more rapidly, and a greater voltage will be induced. The magnitude of the induced voltage across a coil is proportional to the number of loops times the rate at which the magnetic field changes within those loops. This summarizes what we've been speaking about, and it is called Faraday's law of induction. Faraday's law of induction can be written as an equation. The induced voltage, or EMF, is directly proportional to the number of loops in a coil and to the rate of change of magnetic field. Magnetic flux or magnetic field means the number of field lines through a device. It's actually equal to B times A. B meaning magnetic field strength, and A is the area of the device. So change of that is delta that, which is written as this symbol, this Greek symbol, and it's measured in Weber's volt seconds.